enable secret contracts. Is everyone hearing me right?
It's perfect.
Yeah, it's perfect. Thank you. So it's permissionless. It's economically incentivized in a proof of stake type of model, and it's compatible with Ethereum. That you can outsource the private parts, the parts that you want to keep private, and continue the rest of the computations on Ethereum. So I think the best way to show how our network is built is by the stakeholders. Similar to Ethereum, we have developers and users that interact with the network, and the workers that are basically nodes that run and execute the computations. So in the first cycle, in the first stage, we have developers which create their applications, which by writing secret contracts and sending them to the Enigma network, which then deploys them and deploys them on the network. Next, once a contract is deployed, so we have a user that can interact now with this contract by submitting encrypted data and sending it as a registered task to Ethereum, and later on executing on the Enigma network. So once a task is sent to the network, the worker is chosen in a weighted lottery. Once the worker is selected, it executes the task. It spreads the updated state across the network, and it then submits the task to Ethereum, which verifies it, and then once it's verified, it sends a payment on the execution to the worker. So basically what we have is a user that encrypts its inputs locally. It sends it into the network where a worker executes the computation. It spreads across all of the network an encrypted state, and then it sends a result back to the user. And there's also an option to send it as an Ethereum fallback. So in this presentation, I would like to focus a bit on the encryption of the inputs. So basically the process includes an encryption of the inputs by the user. The worker then needs to decrypt it in a secure environment. It later on needs to encrypt the output and send it back to the user, which wants to see the result. So the process goes like this. It's a user. It sends a request to the Enigma contract sitting on Ethereum, and it receives back the worker ID, which is going to work on the task. Then it exchanges keys with the worker and the user exchange a key in BP-Hyman protocol. It's supposed to be very secure because we generate new keys every computation. Then once the key exchange once there was a key exchange, so the worker and the user can interact with data which is encrypted, and only they can view it. So that's more or less it. And now I'd like to show you a short demo of a coin mixer that we implemented on our network. So coin mixing is basically a way for privacy, transactional privacy achievement. It conceals the history of transactions, and the reason it's so unique on our network is that it brings lots of benefits, usability and cost benefits. So we call it salad. Salad is good for you, as we all know. And the main advantage is that it's non-custodial and it's not interactive. It's not interactive. It requires a quorum, and later on we hope that it also would use a time threshold. So this is a short UI demo that someone from our community created.
You have to go to the other side of the, put the cursor all the way to the right. Like, it's two screens, so yeah.
Okay, so this is a short UI implementation that someone from our community got together. So it's in our GitHub, so you're welcome to see it. So basically, we're showing you. You see anything here? Okay. So basically, we decided on a quorum of 4. Say you want to send an amount to a recipient address. You create a sender address from which you're going to send the amount. You're going to add the new recipient address and the amount you want to send to him. You submit it, and once it gets to 4, it automatically notifies itself, and all of the transactions are done underneath, behind the scenes. So I would like to show you now how this actually works. So a user sends a deposit to the deposit contract that's sitting on Ethereum. Once it sends it, it gets back a public key, which with it he encrypts the destination address. He sends it to a relayer that manages all of the operation. There are many other users that do the same operation, and once a quorum is reached, so the operator creates a new deal. So a new deal, once a new deal once he has an amount of participants, he just adds it into the deal, sends it to the Enigma network, to the secret contract sitting there, and that secret contract reorders all of the addresses and sends it back to the deposit contract sitting on Ethereum, which creates the deposits and sends the transactions to the new recipient addresses. So, as I mentioned earlier, the Enigma implementation it improves the cost by batching all of the transactions into one batch, and by usability that's not interactive. As opposed to ZK, you need more than one interaction with the network. Here you only need one, and you can be sure that the transaction is going to be going into the recipient address. So, as I said, so this is pretty much a prototype. So we still have a couple of open questions as opposed to this demo. So, what should be the right quorum in order to prevent the revealing of the transactions to the new recipient addresses. The question is how we can enable an arbitrary split size deposit as opposed to a fixed size that it currently is in. So there are many other applications that are working with that would be working on Enigma. We have in the government side, we have an option of voting the applications that are done completely private, and there are many games that need randomness that we don't want to And I hope there are going to be many different applications that will be able to run on our network. So that's more or less it. Thank you very much. If this interests you, you're welcome to join us on any of these networks. And that's it. Thank you.
Last time I was on stage in Berlin was the day the wall fell. I was at the Cryptography conference, which just happened to be here at that time. But before that, I actually went to Checkpoint Charlie, got my reservations, came back, and then went to Dresden and several other places in East Germany. And that was quite an experience. Anyways, how many of you heard of Cambridge Analytica and Facebook and WeChat? WeChat? Has anyone heard of WeChat? Okay, well, just forget about those people because they're doomed. Okay, we found a way to totally decentralize chat and payments that has absolutely no metadata. We shred all the metadata in real time. And that is not something that you can just do by a combination of known techniques. I had to work really hard to find a real, genuine scientific breakthrough to allow that to be done. And I will show you in a few minutes how we achieve that. Okay? This is our Elixxir project. We're going to be making some very important announcements tomorrow at Web3, which, because of the press thing, I can't tell you here. So you'll have to come to Web3 to hear them. But basically, our requirements, oh, sorry, I guess we should be in presentation mode here. Our requirements are, for a blockchain, we also need a level of privacy that you've not seen anywhere yet. So in order to achieve unlinkability of, say, 100,000 transactions that come in every few seconds to 100,000 that come out every few seconds, those transactions have to be containerized into uniformly sized elements. They all have to move through 8 stages, 8 different nodes around the world, and each node has to make a completely independent permutation, reorganization, shuffle, if you will, where all possible shuffles are equally likely. That's done 8 successive times by 8 independent nodes located around the world, and ultimately, which nodes are going to do that are going to be chosen only very briefly in advance. So from the whole set of, say, 1,000 nodes, roughly speaking, 8 will be chosen independently, uniformly at random, and they will be the ones doing the mixing. Then we need to be able to handle, like I said, like 100,000 transactions every few seconds. And I'm not going to give you all these, or maybe 1 million. If I'm really lucky. Visa only does like a couple thousand a second, and they're about 40% of global transactions. So 100,000 chat, and hopefully this will come back. Chat combined with payment, so no one will know whether you're sending chat messages or payment messages, or whether you're switching, what you're receiving, and then security. Now, how many people think that one of the biggest governments in the world would be incapable of taking down your favorite blockchain? No one thinks so. You think they could do it if they wanted, right? You think they cannot? Well, you know, years ago, I had an office in Amsterdam near here, and we had an open process. It was the only one to review cryptographic technology. So people would submit their codes, and we would try to break them by an academic open process. The only other process that exists is one run by your friends, yes, NSA, you said it, I didn't say it. Officially, it's run by the National Institute of Standards, but the final decisions and the parameters and so on are decided on by our friends at the National Security Agency, who recently, Snowden told us, are executing the full tape, right? They're capturing every single message that goes across the web and the internet. So that means that, for instance, the Tor project that they've been paying for a decade, they know every single person that's using it, who's sending to who, and everything else. But the codes that are used, you hear about strong encryption. How many of you have heard that phrase, strong encryption? Who made that up? I don't know. Those are not the codes that governments use to protect their own secrets. Those are the standards that they've promulgated for us to use. Okay, and you think that they're inviolable? How many people would be willing to? Why don't they use them themselves for safe command and control of nuclear weapons? Well, so maybe, anyway, so we need a new level of security in the blockchain space if we want to really get serious. So I'm talking about addressing the consumer population of the planet. This is messaging and payments for ordinary people, not something that's for a limited set of people. So we'll need quantum-resistant cryptography that's based on random codes. You cannot use these systems that are recommended to us. So the bottom line from the Cambridge Analytica announcement, right, and everything that's come out is that I think many people around the world are starting to recognize this over the last 18 months, right, that the whole game is not just encrypting the content of the data, but who talks to who and when. Okay. All right, I'm going to try to explain it, but it's a lot better than voiceover. So here's my amateur impersonation. When Alice wants to send a message to Bob, she doesn't want anyone else to know that she's communicating with Bob. So she puts the envelope, the message in an envelope, which basically protects message content, as we've talked about. That's the end-to-end encryption. But how can she keep who she's talking to, the fact that she's talking to Bob Siegel? Well, we have to send the message through these 8 nodes that I mentioned. Each one rearranges all the messages and sends them on to the next node. And this is a process, so these guys are all trying, at each stage of the message are being encrypted, so you can't see what's going in and out. So Bob gets it, no one knows that he got the message, but actually we can send an acknowledgement back through the same path. And then we destroy the information. So for the next batch, it's a whole different set that's used. The reason that the mixing that I invented in the 80s won't work smartphone to smartphone in 10 seconds is because it's way too much encryption. So what we do in Elixxir is we pre-compute all this stuff. It's done in advance, and so we create all the random rearrangements in advance, and so when the messages come through, they can fly through those tubes, as you saw. We can also send payments, but those payments are done differently from all other blockchains. They're done in binary denominated coin values. So 1 cent, 2 cent, 4, 8, 16, 32 cent, and like that. So that the amount of payment does not reveal who's paying, which wallet is paying which wallet. In fact, there's no wallet. It's through digital cash, and this creates an environment where everyone can have a protected sphere in which they can communicate and make payments for information, for instance, to their friends and family. And I guess this will be our last slide together, unless it comes to Web3. Basically, we announced our project just under a year ago in Singapore, and we have actually really come through where we have now the AlphaNet running, and we have about 2,500 users signed up on our Elixxir app and will be branded, and they will be given access to our AlphaNet, which is running, and it will be available by the end of this month. So we're starting our own social networking system with the 2,500 people or plus now that have signed up and downloaded the app. And we have also 20 to 30 groups that have signed up for our Arrow SDK, so that we have SDKs that completely give access to sending and receiving of messages and the forming of messages, libraries, and all that for all kinds of platforms using GoLang. So then by the end of the year, we've got over 700 nodes that have signed up to a very open process where we survey, find out what people wanted in node operators and so on. Now we've completed the open selection process, and we've divided the nodes, beta node operators up into 3 teams, and so we're all set for when the beta node will, VNet will go live, and then we'll have VNet next year. So if you want to hear some really exciting news, come tomorrow morning at 10 to 3. So thanks very much, everyone. Thank you.
And so for about 10 years, I've been doing machine learning. I worked at one of the Google companies mentioned before, research.
Really? No. Just make it up.
Standards. Part of it, I realized that they can understand more of Google data. Also, I work with TensorFlow, which is one of the open source projects that Google put out. It's right now, probably top biggest on GitHub by stars. So we're going to do that. So I'll just kind of keep moving because we have a little time. But so Near Protocol is pretty much a smart contract blockchain, and the idea is to build infrastructure where every developer can actually build an application, right? You don't need to be like a blockchain developer, study for multiple months to actually write the first smart contract. And as you do that, right, as you get closer to web developers who want to build applications, you can realize you also want users, right? So Near Protocol is focused on experience. Scalability is just a part of it, right? If you want to get a lot of users, you will need to have scalable applications. Now, I'm not going to show too much our protocol, so if you want to learn more how it actually works, we have a ton of YouTube videos which explain exactly. Instead, today, because we're Web3 and there's a lot of talk about card chains and separate app chains, I want to talk about how do actually application chains and dApps compare, right? Why would you run the application chain versus a dApp? So, who here familiar with dApps? Give me more participation. Come on, guys. You're at the blockchain conference. So to compare with application chain, right? This is something where you have one specific chain run versus one specific application, right? I decided, hey, I have this mega idea. I'm gonna go and start my own blockchain, right? And usually there's 2 ways you can do it. One is you can start a sovereign chain. So usually Cosmos is an SDK to do that. You spin up a SDK, you spin up a chain, boom, on your own. Great, not saying win, but options are there. Now, there's actually type security, right? So this is where Polkadot, what it's offering is a shared security, where instead of you building up your own security of the system, you can rely on a shared security and kind of don't need to spend much time on that. So Plasma actually is very similar to this, where shared security is Ethereum. So if you think of it, Plasma software chain is Ethereum. Nice. Now, when you're building your own chain, you actually need to figure out your own cryptocurrency, right? Because if you think of it, you actually need to get validated as a lot of users to start participating in the blockchain. I'll get one of those. Usually, you will not write the code from scratch, right? So you'll use substrate, obfuscate, the others. And yes, you need to use all cryptocurrency. Now, so let's start with actual security. I'm not talking about cryptocurrency security. I'm talking about real, breaking stuff, hacking, etc. Right? When you're building a dApp, right, it executes an DBASM for VM for Ethereum, with WebAssembly for do blockchain, near, window, etc., edgeware. And what it actually gives you is actually gives you the ability to write code that might not be that secure. Because if you're writing an app chain, you're actually writing native code. And if you messed up anywhere, this actually will explode on the node and compromise the system or the values. So this is pretty scary. Now, on top of this, because it's a VM, we actually have metering, right? We have gas, which measures how much usage has this application had and cuts it off as soon as that runs out, right? Again, when you're writing an app chain, you don't have that. So you either need to add it manually, so you manually count how much usage you get, or you can have transactions that may take a gigabyte space, RAM, on your node, and again, we're actually about it. If you have one of the consensuses that actually slashes or offline, this is the greatest way to get a bunch of people slashed in one go. Now, again, when you're launching your own app chain, you're relying on the stack, right? You're relying on the substrate, on a cluster certificate. Now, yes, there's great guys building it, and they are blockchain experts, they do know about security, they have security review, but you are taking the risk. So when you launch an app chain, you're actually taking the risk of running this blockchain. And full stack from networking to consensus to app code, all of this is owned by you. If there's an issue, if there's a bug, if there's security vulnerability, it's on you to fix it, it's on you to maintain it. Versus if you're running a dApp on Ethereum, on name protocol, obviously here, then the security risk that you have is just your app code. Right? So if you need to do a security review, you do yours for application code, you don't need to make sure that the stack is working, right? Because there's multiple people already relying on the same stack, and it's the same exact code running together, right? This is the difference. Because like when you're running, for example, software, the Cosmos, you're actually running different versions of what's running on the application. Right? Binance running its own, doing its own. Maybe there's a bug, maybe Binance fixed something and didn't tell you, and now it knows how to hack into everything. We don't know. Alright, so let's go to performance. That's where app chains actually win, right? Not everything is so in. So app chains, like what main benefit is actually the performance of the system, right? Like if I'm running my own application and I really need to believe that performance is a key of this application, right? You get a full performance, right? There's no lot of transactions happening, there's no kind of limitations to what you do. And VM does have no impact, right? So VM is relatively slow, everything is faster, it's still pretty slow. So, like, you do remove this boundary. The interesting thing is that you kind of need to optimize your own code, right? You need to make sure that you do not miss out on. And with the dApp, you actually can rely a little bit on protocol kind of continuously improving and adding, maybe accelerating the maybe figuring out better tricks to speed up. So this is kind of like interesting thing. Now, specifically in sharded blockchains, which is what Near is, what is, to other blockchains, what's interesting now is that you don't actually, your application is not sharing the chain with everything. It only shares with other applications in the shard. Now, with Team 2.0, it's hard to say right now because we don't actually know exactly what the design is for the phase one, as they call it. But for example, for Near, one of the things we're doing is what we call dynamic shards. So this idea that you actually reallocate applications to shards depending on usage. So if your application specifically needs a full shard of performance, right? You actually allocate it to like not being another part, millions of users buying crypto keys, making that, it's a crypto key atom. You actually can get full performance on the shard. Like we'll just move out every other application block dynamic. So that's kind of the idea that like sharded blockchains are actually very different from like a blockchain with a limited capacity. Again, you can learn a lot more on that. I'm not going to go too much. Now, economics is very different, right? So you're running your own blockchain. Like, let's say, imagine we're the hackathon. You came in, you're like, okay, I'm going to build a blockchain. Let's start this, write some code, spin it up, and then as well. I need my own app chain, so I need some blockchain that producers, right? So I need some folks who actually care about my blockchain, produce blocks, validate them, collect transactions, control this good work. Now I actually need some pages, right? So I need my token. Now I need my token, I need to actually build up liquidity for this, right? Because validators actually have expenses in dollars. You actually need to go and sell stuff. So you actually need to go and figure out an exchange. This is like not a The part of it is if you pretty much paying them for running a full chain, right? Like you're actually paying them exactly how much a validator would spend plus some margin on running a full chain. So if you're not using the full chain, right? If your application actually uses only 10% of the throughput of the chain, you're actually overpaying. That's that's how it is. So if you think of like dApps, the payment that's done is only paid for the amount that is being used, right? So here kind of my another twist on this. When you do an application chain, it's kind of like a dedicated hardware, right? It's expensive to buy, you set it up, you configure it, you spend like a lot of DevOps time to figure it out, but you get a lot of performance improvements from it. Or you can just ship your app to cloud, get it to work, scale it out, it's fast and easy, and you pay for how much you use, right? So there's like obviously trade-offs here, but it definitely allows you to kind of quickly start from there. The one thing that's you should not forget was the shared tech security. You actually need to win an auction on, for example, a Polkadot, right? So there's only like a limited number of slots for card chains. If you want to have a shared security, you actually need to get into that, which can be pretty high. Now, one thing that people really like with separate chains, especially like a Cosmos separate chain, sovereign chain, is not depending on anybody's governance. So, which seems like a good idea, right? You don't want to depend on more stuff. Now, the problems here start is that, well, when you launch it, you actually need to have governance support. Because if you don't have it working, then you will not be able to upgrade to something that's kind of an idea. Versus when you deploy the app, right, you can start with like, hey, I'm going to say what the app does. If people don't like it this way, they can use it later when I actually make it more expensive, right? So you can start like creating the app yourself, then maybe switch it to a community, and then maybe switch it to a DAO, just like look at the folder or whatever. With blockchain, you kind of need to like start with something that's pretty advanced already. You can not just say like, hey, I'll have a key that will operate over nodes in the blockchain to produce blocks, right? Because you actually have to have access to their machine, right? So they will not go for it. And if you have this tech security, right, it actually depends on the governance of the chain. So if you have a Plasma and you have a Ethereum, right, Ethereum governance can kick you out and can modify the state. Same with Polkadot. Polkadot governance can kick you out from the chain. So there is like, yes, there is flexibility, but if you do want shared security, you do need to pay for it by the governance. And then the interesting point is right now there's like 100 million plus of actual validators, professional validators on the market. So if you're talking about proof of stake, if you're launching a new chain, chances are all of the validators are validators of all of the other chains. So if you think of it, hey, this validator of Cosmos is validating my chain as well. And I'm trying to do something that, for example, hurts Cosmos. What is their decision making going to be? If they are invested in Cosmos, right? Like they are like this is governance of like validators, right? Most of the time. And like token holders. So if you have already like all kinds of translation because it's the same people, you actually don't have to mention the name. That's just something to think about. Now, the last part I wanted to mention is level 2. Think of it, the speed of deployment, right? Like with dApps, using some of the modern blockchains, which have like online ID and tooling. First app you can deploy in 2 seconds. And then you can quickly iterate, upgrade the code, figure out what works, whether on the key, get some user feedback, launch an application, maybe build part of it. And then if it's like app chain, Cosmos software is great. In one day you can actually launch your own blockchain, which is really cool. But it's still slow, and you actually need to like drop and go, figure out how it works, actually know the whole integration. And launch is a big event because you need to align all the block producers, exchanges, wallets, integrations, all the partnerships to make sure your chain is actually successful. But it's just a very different level of involvement that you need to do. So in general, like I want to kind of emphasize that app chains are very well suited for like infrastructure focused applications, right? So if you need to modify consensus, if you need to integrate somewhere with storage or something else, that's a great use case. The access also, because if you think of it, the access is something that doesn't want to share the secret with anybody else. Right? As soon as somebody else makes up transactions, they're actually starting to do the front line and go down. The dApps is where we actually want the application to be, right? Scaling, DeFi, like all kind of supply chain, healthcare, all kind of tracking things, and open that, which we believe like a way to centralize it again. Now, if you disagree with me, please tell me, because like I'm writing blog posts and I want to feedback on this. That's why this is pretty controversial stuff. But yeah, this is pretty much my talk. If you want to learn more about here, so we have our online ID where you can monitor dApp in 15 seconds. You can join our beta program, so we help you build that dApps and with some incentives for doing that. That's the program, and we have validator stakeholders coming up. And also just to kind of continue showing, we have whiteboard series where we actually talk with almost like a lot of major blockchain protocols from Ethereum to Polkadot, Cosmos to Plasma, etc., where we actually have very dApps how technically work, what are the models we have. So it's really cool. Our investors say that we do this for them. And we can do questions later. But yeah, follow me and tell me if I'm wrong.
Have questions about the end?
So, blockchains is about scalability. Okay? And so basically, despite all the buzz that we have in the community of huge performance of the blockchain systems, the reality is a little bit different than that. Okay? So if you look at Bitcoin, Core, it has 3 TPS here. If you look at Ethereum, it has 10 TPS or so. Of course, we're having these newer blockchain systems, but I'm not aware of any that runs a large number of TPS of transactions per second. And to be really useful in the real world, what we do need scalability. And I'll give you, I hope you already agree with me on this point, but I'll try to give you just a few examples. So just credit cards, of course, the famous example, 5,000 TPS rate. If you just count the number of cards in US and assume each one is from a tank once a week, just for that you need 450 TPS. Okay? If you look at the number of vending machines and assume each is used 4 times a day, just for that you need 1,000 TPS. And whenever we talk about blockchains, people have a tendency to talk about these super cool and super new applications like machine-to-machine communications, 70,000, 50,000 TPS, millions of TPS, and it's a bit embarrassing to talk about all these high TPS rates, when the reality is really much different than that. And so basically what we are doing, I'm not here to sell you another blockchain. We are not a blockchain. Okay? We are a networking infrastructure that tries to help all other blockchains to get scalability. Okay? This is why we call ourselves layer 0, because we sit below the layer 1, which is the consensus layer, and we can work, we hope we can help everybody to get to high TPS scores. Okay? How? I'm going to try to explain this. Okay? So let's start from scratch. I know you guys must know this, but maybe somebody doesn't. So let's go from the beginning. Okay? So in Bitcoin, a transaction is 540 bucks. Okay. This is, I'm sending 1 Bitcoin to somebody else. 1 Bitcoin these days is a lot of money, but that is 540 bucks. Okay? If there is this parameter in Bitcoin called block size, there is 1 megabyte currently. So if you do a little bit calculation and think how many transactions you can put in a single block, that ends up being about 1,900 transactions can be generated every minute. Okay? If you do a little bit more calculation and more minutes per seconds, you're going to end up with this famous 3 TPS per second. Okay? This is where the limit comes into play. Okay? And just by looking at this very simple slide, you can see the key idea behind what we are doing and how we are trying to push things through. So the key limiting factor here is this 1 megabyte every 10 minutes. Why is it 1 megabyte every 10 minutes? People are telling us if we increase this number, it's going to be the end of the world, things are going to fall apart, and it's not going to work. So the question But here, if we decide to increase this block size or decrease the time between these blocks, then we should be able to increase the blockchain capacity. And so maybe I just came up with a great idea, and maybe this is where my talk ends because I just solved this scalability problem. I'm just telling you, let's send more data, and hence we're going to have a larger capacity. Now, people tried that, and it didn't really work so well. I'm showing a result, and I'm not going to name the particular project, but there was a case once, maybe a year ago, where people said, hey, let's increase the block size, and it took 20 minutes for a block to propagate to the network. Okay? And people, and I'm not going to tell you what happened, and I don't know what nobody knows, but I mean, the talk in the community was like, hey, something is wrong with the world, how could it be that you send a 30 megabyte block and it takes 20 minutes? What is going on? What can go wrong? I am a professor of computer networks, and I can tell you that there's 1,000 places where things can go wrong when you want to send 30 megabytes on the internet. We all know how it works, but let me try to explain it. So basically, here is, assume you have one blockchain node and you have another blockchain node on the other side of the world. Okay. When this particular miner is sending that particular block to the rest of the world, what is going on? It is going through multiple autonomous systems. For example, if this guy is in Europe and that guy is in China, it takes more than 20 different networks to send this particular piece of data to the other part of the world. Okay? And the performance on any of these particular parts of the network may not be as good. And actually, networking is a place where the worst guy or network pod is the one that decides how poorly things are going to go with your blockchain system. Okay, that's the bad news. So just going from one node to another, there's 1,000 places where things can go wrong. Now, the trouble with peer-to-peer systems, this is just the beginning of the problem. Once this guy sends to this node in the middle, these peers have to send to there. Okay? And we have no idea whether these guys know what they're doing and how they can set up their machines. So not only do we depend on the network, but we also depend on all other miners along the path. So it becomes, there's even more than 1,000 places where things can go wrong. So all these things that I try to explain very quickly. What is it we are doing and how we're doing? So what we are doing, we're building a thing called the blockchain distribution network. Okay, this is similar to a content distribution network, only this really is tailored toward blockchains, and hence this is what we call the blockchain distribution network. So in our approach, what we are doing on behalf of all these different blockchain systems, we are streaming both the transactions and blocks through our network on the internet. Okay? Because we are sending the transactions before this particular blocks are mined, we're capable of significantly reducing the amount of data that it takes to send when a new block is mined. How is it possible? Well, the same 545 transaction that I was just talking about, in our internal world becomes 4 bytes. This is just a number that we assign to the particular transaction in the system. And hence, once a new block is mined, which could be the same 30 megabytes that we just discussed, took 20 minutes in another system to go through, in our case, this becomes a tiny piece of data which is just 200 kilobytes. And hence, instead of sending a huge file of 30 megabytes, we send a tiny web page that we have to distribute through our network. Okay? This is number one thing. The second thing that we're doing is that we're doing a thing called streaming or cut-through routing. Okay? How does this work? So here is the miner that is just sending a data, a block, to our network. Remember, this thing is already more than 100 times shorter than it is in the conventional system because, as I explained, we are doing this significant compression within our system. So as soon as the first bits of this particular block reach our system, without checking whether this is a good block or not, we are already transmitting this node is already transmitting this data to the rest of the system. Okay? So what can happen is shown in this picture. While this guy still didn't finish sending any of the entirety of its data because it still has a few bits to send. The first bits of this block already started arriving to other blockchain nodes, to other miners and whoever is connected to this particular blockchain. So here we get another boost. So to summarize, what we are building is a broadcast layer for blockchains with these three things. First, we are significantly compressing the data. Second, instead of having 1,000 places where things can go wrong, that I explained initially, here we have really three links. The first one is from the miner to the blockchain node, and given that this our network is global, this particular path can be very good. Then we have another link within the blockchain, within bloXroute network itself, and the third link is again from these blockchain nodes to from bloXroute node to the blockchain nodes. And another, the third important thing is, if you remember, I told you, well, in the conventional blockchain system, you do depend on what other miners are doing, how good or bad their performance is. In our case, as you can see, every miner or every blockchain node is directly connected to all other nodes in the system. Okay, so this is what we call a broadcast layer. And so I'm not going to bug you significantly with this, but it's all, I'm a professor, and writing papers is relatively easy. You know, in academia, we say, hey, this is a great idea, here are a few examples, and we claim success. In the real world, it takes a lot of time to actually get to the standards and to actually make it work, and I'm a witness of that thing, so it took us some time, a year, to show that this can actually work for the Bitcoin network itself. Okay, so what we did, we took the Bitcoin Cash source code and we put it on top of bloXroute. We were capable of pushing this basic blockchain system to more than 1,000 transactions per second. Okay, so just to give you some ideas, there were more than 300 nodes, 30 miners all over the world, and we were capable of pushing 50 to 100 megabytes every minute, and has significantly increased risk. Now, the title of my talk is about net neutrality. So what the heck is all that about? So thus far, what I tried to convince you, and I hopefully convince you, that you can use these advanced networking methods to speed up blockchain. And that is all good and fine, but the trouble with this is that once you have this very advanced network in the middle, that network itself can kill the whole beauty of the blockchain systems, because blockchains themselves are distributed systems where no single entity can own the system or can decide which transaction goes in and gets out. Okay? So this net neutrality part, this is actually where my expertise comes into play, and I can talk about this for 2 hours, and I'm going to spare you with, don't worry, you're not going to listen to me for another 2 hours, but I'm just going to give you a high-level idea on what it means to be neutral in the context of blockchains, so that we can actually still have blockchains that their security model is still preserved while they are capable of boosting their performance with the bloXroute network. And just to be as straightforward as I can, the definition of global net neutrality is if anybody comes to us, bloXroute, and says, hey man, we have this little transaction and we know that these are some bad guys doing some very bad things. So please, whenever you see this little transaction, call us or don't let it propagate to the network. You're going to do a lot of good to the world. Our answer to that question is, dear whoever, thank you so much for your kindness, and we equally don't like any of these bad guys, and we will be happy to help. But unfortunately, there's nothing we can do to help with this, because the design of our network is such that we are incapable of doing that. Either it's just not possible. Why is that not possible? Because before any block is sent into our network, the endpoint is encrypted. Okay? And our network blindly propagates this data to our network, Only after the data is propagated to the entire system, only then the peers among themselves exchange keys, and they are capable of decrypting this data and moving forward. Okay? So, and of course, this is just one part of Neutrality. It's a much bigger story, but in short, this is the essence of what we're doing. I'm going to skip through a number of other things, such as I want to say one thing. As we speak, I think in addition to working with Bitcoin Cash, currently we are having the test with the Ethereum network. And if my clock is right, it's been about 20 minutes already, so I don't have any data. I can't share any great news as of now. But we are working with Ethereum miners all around the world and many others who joined our test. And because we are in the business of helping all blockchains scale and move on. So if you are a blockchain project and you do think that you're going to be successful enough that you're going to have a lot of transactions going through the network, going through your system, we can help you move on and scale. So all that said, this slide is intended to show that we really want to help the entire community, all different blockchains, and hence our thinking is that no single blockchain should fail because they can't. They might still fail because they are incapable of building enough traffic in their network or for many other reasons, but scale shouldn't be one of those things. And with that said, I'm gonna stop now, and I think I did my 15 minutes. Thank you so much, everybody. Thank you.
Besides just already or is it an outbreak?
So as I explained, our key idea is to have a peer-auditable central network. On top of that, you will have the concept of backup network. That means any community that is served by bloXroute, there are other servers in the backend, so that in case anything goes wrong technically with bloXroute, or for some reason it becomes evil, and as I explained, the entire network can go evil or not. I mean, there's nothing in between. Then there is the concept of backup networks, which can then take over this because our code is open source, and hence there's a way for people to not rely 100% on us, but to have a number of these backup networks. They are not going to be expensive because they're not going to allow traffic, but they're going to be an additional level of security for people so that they are not going to lose their business in case something goes wrong with us.
What would happen if you other agencies that contract you like you don't know releasing stuff or like
So the question was, what happens if somebody comes to us and says, "Hey, you guys have to shut down"? Basically, I mean, we do have our presence in different countries, and hence our code is running at different providers all around the world. So this is one level of backing off kind of getting these types of situations. Again, is that our database, which is the open source code that sits on the blockchain nodes, is already instructed so that they can go on and reconnect to any other backup network that exists out there. And moreover, of course, all these nodes are still talking to each other in a peer-to-peer fashion. So the end of the world happens, and the peer-to-peer communication is still necessary there, not just for working us, but in case that our network falls and all other backup network falls, which is not easy to happen. But in such a case, the integrity of the blockchain is still preserved. I'm not going to answer any other question.
You talked about work on
Everything Alex is great on that. No, Alex, no, the guy from
Sure. So the question is, incentivized testnets, and I think it's a separate question, switching from Ethereum to let's call it blockchain. So incentivized testnet is an idea that you actually want to get more validators participating, and because it's proof of stake, you actually need to have a bunch of validators depending on actually participating, otherwise they'll have a centralization, so it will work when people can later join because they have stake. So, and the considerations here, right, is mostly around, like, you want this validators to like actually bring some interesting skills to the community, right? So a lot of like small professional validators actually have some pretty good like engineering teams, good backgrounds from DevOps, etc. So the idea there is mostly around like how can we kind of challenge them in a way where the community challenge their network and they actually build tools that are really useful for community to go forward. So for example, how can we like break our network? What kind of modifications and processes that we can do, and that is pretty much what the most of the report is. So like actually just running our nodes, anybody who like familiar with Google Cloud can set it up in kind of 15 minutes. We actually got it in our team, non-engineers, our employees non-engineers set up the node and start playing. So it's like pretty easy, like follow implementation. So that's not the hard part. The hard part is like actually like exercise. And then the switching part, the questions here is mostly around like, there's a lot of options right now. There's a lot of things that's pretty needed. You know, we are like I think multiple blockchains like Quadro. that I know, yes. But you know, and then there's like 15 events right now where there's like 5 blockchains each. So that's kind of the biggest question right now. It's like when people, and there's a lot of Ethereum developers who are like, well, Ethereum, you know, not moving very fast. They're, you know, showing like they have the state 0 ready, but it's unclear when actually the software part will start. But right now, it's just blockchain. There's no transaction. So if you think of it, they're like processing more than something, but they don't. It's unclear what here. Like, I mean, our value prop is experience, but there's a lot of like, privacy, the other values, right, that people can kind of target, and this is where it's finding your customer, working with them. That's what we like our data for cloud connects with us. We will help you fundraise, we'll help you development, we'll help you like mentor you, and I
was just going to add, like, there is a level of implementation that's serious when you do any kind of DevOps, let alone something complicated, a little more complicated, like blockchain implementation. And you get caught, you have this issue where you want to basically have people around the world, and you start looking at, you know, we call it binning, but geographical binning, and you want involvement of younger people and people in every country. And then you realize you have a technical challenge to actually like make stuff work. So when you end up doing this kind of having a set process. So you sort of say, we need to get some more sophisticated people first, make sure it works, and then you realize we better start helping develop sort of the next generation. And this is something that, like, if you look back, like at Microsoft, when they started with the certified network engineers, what Unity did in like 40 different countries was to bring young people all over the world and train them. And it turned out, like Microsoft at one time was the largest internet company, training company in the world, and it was largely training people to support their network. So, like, we have to do the same thing. We have to like find young people and bring them to the country, or places like Microsoft outstrip us.
How do you choose those? Suppose you run a class on a fraction of the nodes. Like, how do you choose them, and how long can I make a program run? Any node is going to be running up. You got to handle them.
Yeah, of course. So choosing the worker in the first phase where you have a weighted battery, they choose workers based on the state that they have in the network. And they're every few blocks, and then decided on a fixed amount. We then decided on a fixed amount of blocks that we're going to change. Every couple of blocks, there's going to be a new random number that will choose a random word for each execution. Now, in order to store the program and store them all across one of the network, every one of the workers has one status, one single contracts stored encrypted on the database, which then if he's the one that's supposed to compute, run a computation, so he gets the keys and he will be able to encrypt the state.
It's kind of library, and you take the book and say,
Yeah, if you're the one that's in charge of the pass, so we're going to have the keys and you'll be able to encrypt them.
Question for Aleksandar. Imagine I'm a new blockchain that you don't support, for example, an online community, and I want to port my blockchain to your platform. So how hard is it? How much work is it? How much I have to change my code?
So if you like Bitcoin, it should be hard because we are already compatible with Bitcoin and any like for Bitcoin and Ethereum and any focus. Ethereum, it seems like there is a lot of those, and so we are still already very compatible with those. And we are in September we're gonna have a list of another 5 to 10 projects that we're going to support. But in principle, the key thing is to build a gateway. A gateway is access to a network. On one side, it speaks the native blockchain language or whatever blockchain you're scaling. And on the other hand, it is speaking the bloXroute language. And hence, what needs to be done is to build this converter from the native blockchain code, basically messages to our messages. And as long as there are not some mystic messages and some very kind of very new and different needs beyond the usual, then it shouldn't be hard in general. So that's definitely my answer. So this is the question that you had, yes. I'll look forward to thinking.
Well, obviously, I'm very competitive, and it's on my slides. So my always thinking has been that at some point we'll start actually consolidating. It's not going to be next year, not going to be in 2 years, but at some point I think one network will win. And this is mostly based on the network effect of these things. If they actually start picking up, it will be so huge. Now for that, there's a lot, like the infrastructure will look very different. Like all of the stack will look very different. So we can talk to that. So right now, I call it like, well, not going to be, some blog posts called it like, explosion, like evolution explosion, right? Where there's a lot of experiments, a lot of trying things out, a lot of seeing what works and out. And the thing is, like, you cannot actually see what works until you actually launch it. Right? That's the problem with like change in general. You cannot like try experiment one thing. You know, like, hey, we'll try sharding, but without all the other stuff, right? Like, nobody will do it, right? So this is the point. Like, you actually need to build a full stack and actually launch it and try it. And then we will start seeing that, like, people picking up and kind of choosing what is the combination of best things and how it fits together. That's like 5 seconds.
I don't have much to say beyond this. I think very similar. It's very similar of network action. We hope that we're going to launch a network. Hopefully, we're going to reveal many functions that we will be able to overcome, and hopefully we will be able to stay. It's
matter of how you expand. I think things going to come and you give us you have more, you would have much more information in order to expand.
Yeah, we're sort of at an unusual starting point since we focused at first entirely on privacy, on a privacy protection platform. So the way Elixxir works, you can effectively message in private data into another blockchain. And so with that said, we have provisions for controlling dApps, sometimes we call it business logic, software running off the chain to a multi-signature so we can check and make sure it ran correctly. But our primary mission was to protect the privacy of the data, not to compete with other blockchains. That said, our sister blockchain, which is a digital currency technology, is designed to reach finality quickly enough to support payment and transfer of value in a matter of seconds, so you can really transact and close on a smartphone. And so I guess our thing would be over time, as people become sensitive to really wanting to kind of like use the blockchain in a sort of modern way, the way that you become accustomed to, sort of hour in, hour out on your smartphone, that what we're doing will become more valuable. Other questions? I guess that is, yeah, thanks very much.